So welcome everybody to this week's problem set on the topic of taxes on savings. So in the last two problem sets, we dealt with questions of chapters 2 to 7. And just one remark, I made a mistake on the description of the problem sets because I said that the problem sets that we had the last 2 weeks would refer to chapters 2 to 6, but of course there were also questions of chapter 7 included. Yeah, so the recap sessions were dealing with chapters 2 to 7. And today we will continue on the regular schedule of the lecture actually, with respect to the topics. So we will now cover chapter 8, which you hopefully have seen in form of slides during the presentations of Galina. And if not, otherwise you simply wait until Monday, and then you will definitely see some slides on this topic, and then you can maybe solve this problem set a little bit easier on your own. Okay, let us start. So, question number 1. Suppose that a person lives for 2 periods, earning $30,000 in income in period 1, during which he consumes or saves for period 2. The interest rate on savings is 10% per year. Draw that person's intertemporal budget constraint. Okay, so we start with a quite simple exercise. So let me just open up a new window. Okay, so what we need to do now is to first draw a coordinate system. So just 1 second. Yeah. So let us do this. So this is sub exercise A. So on the x-axis, let me just put this a little bit more to the right. On the x-axis, we will have consumption in period 1. So this is consumption period 1. Also put this a little bit more to the right because I will need the space. And on the y-axis, we will have consumption period 2. We have a total income in period 1, or an earnings of $30,000. So the maximum that we can consume in the first period is 30,000. Okay, we'll just put it here. So that's the most that we can consume in the first period. Now in the second period, we can, if we do not consume anything at all in the first period, and we take everything that we got into the second period, what will basically happen is that we get interest rates on our earnings, and the interest rates are 10%. So what can we maximally consume in period 2? So it's 30,000 times 1 plus 0.1, which is the interest rate, so it's 10%. And this is then 33,000. So then, again, this will be not very precise, but you will get what I mean here. So this is $33,000. So we can slightly consume more than what so if we put all our consumption in one period, we can obviously consume more in period 2 than in period 1 because we get interest rates. And yeah, in order to draw the intertemporal budget constraint, we simply now connect the 2 points here with each other, and any point on this budget constraint here is basically giving us a bundle of consumption in period 1 and period 2, which is feasible given that we have an interest rate of 10%. Okay, question number B, or sub-question number B. Draw that person's intertemporal budget constraint if the government interest government taxes interests at the rate of 30%. So now the story is a little bit different. So now we basically have a tax of 30% on the interest that we get. So let me just write here without taxes. So this is the situation without taxes. And now I will consider a situation with taxes. I will just switch the color to distinguish the two cases better. So if we have taxes on interest rates, taxes of 30%, this obviously decreases the amount that we can carry over to the next period if we are saving, because we have to simply pay taxes on it. Now, what doesn't change is the consumption period 1, so the maximal consumption, because there we do not pay any taxes at all. We only pay taxes if we save and want to consume in the second period. Therefore, what all happens is that the y-intercept will change. So we can still carry over or save a maximum of $30,000. This will be multiplied with 1 plus 0.1 times, and now we adjust this for the tax rate, so 1 minus 0.3. Now this part here will make sure that we deduct the taxes from the savings that we are making, and if you calculate this, what you will get is 32,100. Now with taxes, this is the maximum amount of savings that we can get. Okay, and if you want to draw it here, it would be somewhere, a little bit closer, but again, this is not a precise drawing, but the story should be clear. So this is 32,100. And now you connect this with the intercept here. And this is the new intertemporal budget constraint, which is now obviously lower than the original one because we simply have to pay taxes on our savings. Okay, let us come to question number 2. Bolivia has 2 tax brackets. The first $20,000 in income is taxed at 10% marginal rate, and income above $20,000 is taxed at 30,000 marginal rate. All income, earned income, nominal interests, dividend, and capital gains income is treated the same. The threshold for the 30% rate is currently indexed for inflation, and the real interest rate is 5%. Sub-exercise A. How does inflation affect the return to savings in Moldova? Compare the likely savings rate when expected inflation is 10% with the likely savings rate when expected inflation is 0. Okay. So what basically happens here, so this is exercise 2, question A, is that inflation reduces the returns to savings because the tax is applied on nominal interest rates or nominal interests. So what information did we have in the exercise? So we had information that the real interest rate is 5%, and the nominal interest rate is then the 5% plus the expected inflation, so it's 15%. So nominal interest rate is 5% plus 10%, so it's equal to 15%. And the issue here is that since the tax system is applied, or the tax is applied on the nominal interest rate, the entire 15% that you basically, in a nominal sense, are saving is taxed. So the entire 15% is taxed, even though 10% is due to inflation. And only 5% represents real returns. Yes, so what you can think of is that if you save $1,000, then so the nominal interest rate is 15%. So in total, what you on the paper will then get is $150, but the 10% inflation eats up like 2/3 of this $150. So $100 is eaten up by inflation. So from $150 that you're really taking to the next period or the next year, $100 are eaten up due to higher prices. And then your real interest rate, so what you really are saving and like the real return of your saving, is only $50, but you still have to pay taxes on the $150 rather than the $50 if the taxes are applied on nominal interest rates rather than on real interest rates. So what will happen? So how will this affect the returns to savings or the savings itself? So there will be two effects. So lower effective return will only lower saving rates if the substitution effect due to this text dominates. So okay, we can also write down what the substitution effect here is, and basically it's the lower rate of returns on savings so if the substitution effect, which is negative, dominates the income effect. So the income effect here is basically that people, if they want to have a particular amount of consumption in the next year or in the next time period, they would need to save more because of the lower rate of return in order to meet the standard. Therefore, one effect could also be that people increase their savings due to this income effect. Yeah, because they want to make sure that they, for instance, have a particular amount of pensions when they stop working. Okay, so people need to save more to hit a particular level of consumption in the next period. So yeah, very simple story actually. So if the returns on savings are decreasing, this means that consumption in the future becomes relatively more expensive than consumption in the present. Therefore, this is the negative substitution effect, which should lower the saving rates because yeah, it's simply more expensive to save, like consume in the, or it becomes relatively more expensive to consume $1 in the future relative to $1 in the present. But at the same time, if you, for instance, let's say the future is the time where you're retired. So then if you, for the time where you're retired, you want to have a fixed amount of net kind of payments per month, which you're getting, then you would need to increase your savings in the present in order to be able to hit this level, because there is less returns on savings which you can somehow carry over. So you can carry over less or more expensively money from the present to the future. Therefore, you need to save more in order to be able to hit the amount of money that you want to get paid out per month in the future. And this is the positive income effect. So this could be the positive income effect. And which ones of the two effects is dominating, it's not clear in this exercise description, and therefore saving rates could increase, but they could also decrease. Okay, sub-exercise B. How would your answer change if the threshold for the 30% were not indexed for inflation? So if there is no index for inflation, so if the threshold, so this is B, if no indexing of the threshold, which basically means that the threshold is fixed. It does not move depending on how inflation will be or expected inflation is. So there is a fixed cutoff of $20,000, and this $20,000 is fixed independent of whether there is very high inflation or whether there is no inflation. And if there is no indexing of the threshold, the inflation could lower returns to savings even more compared to A, at least for some individuals. And the reason is simply because if there is no indexing of this threshold, what could happen is that the inflation will push some individuals into higher tax brackets when they get older. Yeah. So inflation could push some individuals into higher tax brackets when they get older. If they get pushed into higher tax brackets, it means that their interest income will be taxed at a higher tax rate. Yeah, so the interest income will be taxed at a higher rate, so 30% instead of 10%, and this reduces their rate of return. But as before, it is not clear whether this not indexing of inflation to the threshold will actually, and as a consequence, the reduced rate of return, it's unclear which impact this will have on savings, because as before, there is a substitution effect, so it becomes relatively more expensive to consume in the future relative to the present. But at the same time, if you want to meet some standard consumption in the some kind of fixed consumption in the future, then you will need to save more in the present in order to hit this level of consumption in the future. Yes, so also here it's unclear whether there will be an increase or a decrease in savings if we are considering people who are pushed into higher brackets due to the inflation. But for some individuals, who are in the 30% tax bracket anyway, will only have an income effect. So they will only have an income effect because simply due to the inflation, their income would increase, and hence there is just this one income effect which they have, which means that a higher percentage of their real income is taxed. Real income is taxed at a higher rate. And the consequence of this is that they will increase their savings rate. Yeah, for those type of individuals who are anyway in the highest tax bracket, there is no change in relative prices. So for them, the relative price of consumption in the future compared to consumption in the present does not change. The only thing which changes is their real income, and hence there is an income effect which will make them save or increase their savings rate in order to be able to meet some kind of high standard in the future. This brings us to sub-exercise. Oh no, I think this is already exercise 3. Yeah. So exercise 3. The government of Mauritania introduces a new insurance program that pays for 100% of unexpected catastrophic medical costs for all its citizens. Before this time, only low-income households had this benefit. Question A. Describe an empirical test of the effects of this policy change on the savings of high-income households in Mauritania. Okay. So, since low-income individuals or households already had this benefit, so the policy applied, or this rule applied on low-income households. Anyway, there is So we do not expect any change with respect to their behavior. But if we expand this policy or this rule to high-income households, there will be a change in the high-income households' behavior, because basically the government is providing some insurance for those households in bad states of the world in the future. So bad states of the world which cover, for instance, unexpected catastrophic medical costs. So if you extend this, so extending benefit to high income households will affect households who had been saving by themselves to cover unexpected costs. For instance, due to medical emergency or something like this. If the government provides this insurance, those households will reduce their savings. Yes, so if before this policy change, the households were putting away some money into the bank account in order to be able to pay for those bills by themselves in case that some unexpected medical emergency happened. Now there is a change because the government is now telling them, if this kind of state of the world appears where you have those costs, there will be an insurance which will pay for those costs, and you don't have to pay for it anymore. All you have to do is that you basically have to pay a monthly fee, like an insurance fee, in order to such that this policy change can be financed actually. So there is a change in the behavior with respect to savings, and now the second part of the question was, or the main part of the question was, how can we kind of test this empirically, what effect this policy has on the households or on the savings of high-income households. So what you can do a very simple test. So simple test. Compare saving rates of high-income households before and after the policy change. So that's a very simple test. So you simply aggregate or calculate the average saving rates of high-income households before there was the policy change, and then you calculate the average saving rates after the policy change, and then you take the difference, and by this you can kind of see the effect of the policy change on savings of high income households in this country. But so there is an issue, but if other factors at the same time could affect saving rates, we need a different approach. So we talked about the difference approach in the second problem set, I think. Yeah. So if there is some other form of reform happening shortly before this policy change, or maybe after this policy change, which could affect saving rates, so not only for high income households, but for all the incomes, then it will be difficult to isolate the effect of this policy change with the simple test that I proposed above here. So we need something more sophisticated. And since we now assumed that those other reforms which are affecting saving rates are affecting all the households, not only high income households, what we can do is that we can use a different approach where basically the low income households are the control group. So low income households are the control group, and high income households are the treatment group. So in order for this empirical strategy to work out, we basically need to make sure that the other reforms affect low-income households and high-income households in the same way. So basically, this means that the low-income households are a valid control group. But if this is the case, then by using this difference approach, we can isolate the effects of other reforms on the behavior and saving rates from this policy change where we introduced this insurance program for high income households. Yeah, and by doing this, we can really get the isolated effect of the policy change. So sub-exercise B, what do you expect to happen to the overall rate of savings in Mauritania? So we can write this down here. So it's a quite short answer. So there is no change for low-income households. High-income households will save less. As a consequence, the overall saving rate decreases. And this finishes this exercise.